Okay, this is a video on how to use GDB. I've got a program up here on the left. The program has a main function which takes a command line argument, and then I pass the first command argument to a function called readFile. In readFile, I call fopen, and then there's about 100 integers in the file, and I have an array of size uh, 2, and I read 2 integers. That's good. And then I'm going to have uh, a null pointer and try to read 20,000 integers into the null pointer, and that should be bad and should cause a crash. So I'm going to compile it and run it, and I get a segmentation fault, so that's to be expected. And then there's two pitfalls here, and so let's do the first pitfall. I'm going to say gdb a.out and then binary file. This is actually both pitfalls in one. So we're going to see one pitfall, we'll fix it, and then we'll see the other pitfall. And if we say run, then it says that it's failing in iofread.c. And if we say up, it says it's failing in read file, but we actually don't know where in this function it's failing. And the reason why is when we compiled, we should have compiled as gcc-g, which adds hints to the debugger about how to interpret the program. And so now if we do this and say run, and we say up, it shows us that we're failing on line 7, which is the first fread command. Now, this is also not correct, and we've fallen into the second pitfall. If we look at the file name is null. And the problem is that we invoked it as gdb a.out binary file. Now GDB looks at every argument and believes that every argument is for itself. And so it looked at a.out, said that's the program name, it saw binary file, and said, I don't know what to do with that, I will silently discard it. And so that is not how we would pass the argument to a.out. Instead, we should say gdb a.out, and then we should say run binary file. And when we do that, now when we type where, we can see that where we're failing is on line 9. So this shows the call stack. We started in main, we called read file, it called something fread, that called something file xsget in, and so on. And if we go up 3 levels, now we're in GCC line 9, this line right here, and we can print B, and we can see that it's null. We could also print fn, well, we could print fn and get a pointer, but then right here I printed dereference of fn, and actually you can see this file struct and all of the data members that are in a file. So we actually don't need to work with these data members very often, but we can see the data members that are part of the file struct. So good. So and then we can look at. I guess there's not a lot else to look at here. If we go up to main, we could print argc. We can really print any of the variables we have. So in my comments below, I've got when I would use GDB and when I'd use Valgrind. So I would use GDB when I have a crash and I wanted to inspect memory. At the time it crashes, that's what we did just here. You can also use it to set a breakpoint. And so here I'm going to say GDB a.out, and then I'm going to say break read file. And so now it set a breakpoint at line 4, and then I can say run binary file. And now it's taken me to the beginning of read file, and the program is running. It's gotten right there, and it's just about to invoke that line of code. And I could say next, and I could say next, and then I could print fn, and I could say next again, and I could print a0 and a1, and that's what we've read out of the file. And then I can say next, and then if I were to say next again, then we would get our crash. By the way, there's also a command called step, and step will move just one step forward, and if you call a function, it will go into that function. Next, we'll just go to the next line of code. So to be really clear, when I was in this line right here and I said next, it did not try to descend into the fopen and show me what was happening inside the fopen. Instead, it just went to the next line and invoked all the instructions for the fopen. Okay, so GDB, because there's a crash or because I want to set a breakpoint and inspect memory. The other thing is Valgrind. So when would I want Valgrind? Well, it's because I want an automated report of memory issues. Maybe because it's crashing. Maybe because it has funny behavior. Or maybe I'm just, like I said paranoid. I'm not trusting that there's no memory issues. And maybe it's all running okay, but I still suspect there might be memory issues. And I'd like to get a report and know. So I can just say Valgrind a.out. And with Valgrind, you do put the arguments on the command line. And when I run valgrind, then it tells me that there's an invalid write from the function in gcc.c line 9, that fread is writing places it shouldn't go. And then later, it tells me there's another problem because it's actually overwritten the stack. And so I've gotten these, and again, it says that happened in gcc.c line 9 as well. And so this is a different way of getting the same information. With Valgrind, I can't interrogate memory, but it will tell me all the problems it sees. With Valgrind, you really want to focus on the first error, because after the first error, it can create additional errors. And so typically, you'd go to the first error, figure out exactly what happened, ignore everything afterwards, fix that first error, and then see if everything afterwards gets better. Okay, hope this was helpful.